Hello, welcome to episode 156 in this series where I'm programming an NES game live from scratch. Let's get just right into it tonight. I'm going to try and keep this episode limited to about an hour, not including my little preamble here. So I'm going to be sure to look at the time before I actually get started with the code work. So I had a good conversation with a gentleman named Felipe about code and code organization, and he had started working on an NES project around the same time I started, and he's made. I mean, he's done a ton of work, and he's finished up his project. But he also, he also works professionally as a game developer, and got interested in NES development by watching my streams and seeing what I was doing. So he reached out to me and basically was like, "Hey, if you want to see how I organize my project, I'm happy to show you because I think it would be useful for you to see. You can do whatever you want with it, but take a look." And I said, "Sure, why not? I mean, it doesn't hurt to look at someone else's project, especially when that person is a professional game developer, and so they are used to working not only in games but in a structured environment." And I think the thing that I know this is definitely yeah, I would say the thing that people don't necessarily realize, and I hadn't thought about myself until recently, but it totally makes sense, is that when you work by yourself or on a project that is not a professional project in the sense of like you're doing it 9 to 5, or ostensibly 9 to 5, and working in an office with other people, you are doing it in a way that works for you, for your lifestyle, for the way that you like to work. And that's true even if you're working with other people on a fun project versus when you're doing something professionally. And when you work as a software developer professionally, there are just certain things that you do after a certain amount of time working professionally that become second nature to the way that you work. Um, and I think that's probably true for game developers too, because I've seen like the way that he organized his project and the way that he organized his tools and everything is not that dissimilar from other projects I've seen, either through Unity projects people were sharing, or even some of the NES dev stuff. Several folks have shared, including Matt Hewson. So I think the thing that happened with my project is, I'm just kind of streaming it. It's sort of casual. It's a learning experience thing, and I wasn't really thinking about how code organization and organization in general, other than getting some semblance of a build pipeline working, even though it's very manual right now, was important to expediting changes to the game and to getting the game done more quickly. Mostly because, one, I was like still, when I was getting started with this, just figuring out how to work with the NES, and then also working with assembler in a way that I could get comfortable with it, and taking higher level concepts that I was very familiar with in terms of just coding in general, and making 2D games with bounding boxes and stuff like that, and turning that into something a little bit more complete. And the neat thing that he showed me was like his tool chain is really sophisticated but simple at the same time. Like, it has some really nice features to it in terms of how he exports all his data and organizes it all, and what he accounts for, in terms of palettes and how he's using his data and whatnot. So I think I don't know how much of his tool stuff that he did is useful for what we're doing, because it's very specific to the game that he was working on. But that said, there's obviously a lot of benefit to the kind of code organization he was doing, and so it's something we should adopt here, and that's something that I'm going to start looking at how we can do this. So I had started doing this a little bit, but I really want to do this a lot more now, and be a little bit more serious, take it a little bit more seriously. So we're going to start by looking at code and looking at how kind of verbose some of it is, and trying to turn it into something a little bit more organized using more function calls, like subroutines and stuff like that. One of the things that I shied away from using was subroutines, mostly because they are a little bit more expensive to use, because of when you jump to a subroutine, there's some stuff that the code does, that the CPU does, that costs more cycles. But I think in the main game loop, we're not really starved for cycles, and so we can afford to do that in the NMI. As he and I discussed, you're pretty limited in terms of how many cycles you have. So we'll kind of leave that as it is right now, and yeah, and see how this all kind of shakes out. Harder to componentize. I mean, it is and it isn't, right? Like, it is if you intertwine your code in such a way that you're really kind of like thinking about it as one whole piece and kind of optimizing that way. But at the same time, that comes at the expense of readability and changeability. Like, how many times have I gone through on the stream and been like, well, what does this do? Because even though it's kind of commented, it's all just a stream of simple instructions, and I have to go back and kind of look at like what the code is actually doing to understand what I was trying to do. Breaking some of those things into subroutines and further subroutines might help that process. Like, certainly in higher level languages, it's easier, I think, to look at code and understand what's going on, provided you're not using code that's like overly syntactically complex, where you have to really be an expert in that syntax to know how things are working. Like, if you're using something like, if anyone watching or listening is familiar with something like RxJS or Link and C#, LANQ, they're very capable frameworks for expressing a lot of functionality in a little bit of code. But the flip side of that is that means that you have to be really well versed in how those frameworks function to understand what your code does. So like, there are limits. I mean, we'll see. We need to kind of see what we want to do here. So one of the cool things that he showed me, I don't know why I never looked at this before, but there is this capability within CA65 called proc, which is like procedure, basically. Let's see, kind of like a macro, but not exactly, because it gives you the same functionality as calling a subroutine, but with the added benefit of doing what we're doing here, where I've created a scope within this subroutine, draw status bar, for example. This is actually a good one to use as just a first attempt at this. So I've wrapped it in this scope. So proc automatically does that for you so that you don't have to. So it's just a syntactical thing. It makes it a little bit easier to understand what's going on. Or I shouldn't even say that. It's not that it's easier to understand what's going on. It's just nicer in terms of it being cleaner, less stuff going on. And so when we build that, you know, there's no difference in terms of the code that's generated. If we go and look at this here. Let's see, where is that? It's in the main assembler file, so why not find that? Oh yeah, so here it is. So what you can see is it did a little bit more than what we were doing before, where you have it's pushing A and transferring X to A and then pushing A again. So it's saving the state of A and X. And then on exit, it's restoring the state of A and X automatically. So you could argue, okay, well that plus the JSR, you know, and the RTS, that's more expensive than having just a label where you're jumping to the function and then jumping out or something like that, right? But again, how much of this is really critical to what I'm doing? Like performance-wise, I don't think we've hit any points other than in the NMI, which, you know, this is maybe one of the few things in the code where it would do that. Oh, no, wait. It's not doing that. I'm doing that. Oh, so it's not even doing that. That's all me. So that doesn't even add that. Ignore what I said. I forgot I had that code in there. So it doesn't even do anything that way. It's just using standard subroutine. If we were to call that, just as an example, MDTA UK, yeah, that's the idea of this code. I just totally wasn't paying attention and didn't see that was there. So it's not doing it. I'm doing it. I was just distracted. So you can see that it's going to jump to 813F, which is here. So this is just the same thing as if I were calling any other function, right? Any other subroutine. So really simple to do. One thing I wanted to look at to make sure I understood properly was, I believe he had done something. I thought I understood this correctly, but let's take a look. So I think what he had done was in his files, he did this to define where that code lives. And then he just uses, I could be misremembering this, but we'll see. Okay, so let's take a look at the documentation here, because this is something new for me also. So include built-in string function. Where is dot include? Include another file. Include files may be nested up to depth. Okay, so this, from what he was saying, it works like include in like C, in C++, where it brings the file in. You need to have the segment here, I believe, so that it knows where that code is going to live in your ROM. So it didn't complain about not being able to find draw status bar. Let's reload and take a look. Draw status bar is there, and so that says that's at 8,000. So let's go back before we do anything else here. Let's add this back to here. So what this should do is this should jump still to the right location in that code segment. Again, if I'm understanding how this all kind of came together. So 816B is now where reset lives. Draw status bar is at 8,000 hex. And that's where that is. So that is actually correct. So, okay, cool. So you'll notice the reason I'm doing this is because like I've got these includes that are just kind of in the middle of the code. And I believe that if you move them, yeah, see if you, oh, that's not going to work because they need to know about some of the types and stuff. So actually, let's move this. Let's do this. So we're going to include a header as a file. And then so that has its own header segment. And then these things should probably come after this. We're going to want to move these other like constants and stuff into a file that's you know, defined before some of these procedure calls because they're necessary. And like, so this scope entity, for example, if you look here, where is that? Right, this structure is defined here. So it's before this, that's not going to work. It's not going to be able to find this and do anything with this. So okay, so let's see what else got broken. File load state. So we're just breaking all of this apart into separate, you know, separate files. So that it's clear like what belongs with what. And it's not polluting our core game source. This is something that I would well, let me see here. I guess I could just do this in a separate file. I mean, they're constants, but do I want all my constants to be in one? All my constants like this constant to be? Yes, the order is contiguous. That's why you need the segment in some of those cases, because you have to define that it's happening in the code ROM bank versus whatever previous segment it was happening in. See, I just created... Let me do this. I'm gonna these are really constants. Where is that? Shouldn't have broken it out into a separate file like that. Putting the constants and variables together makes it easier to do trial and error, or have a single place for managing them. How do you mean? Process. So I'm going to move the projectile into its own file here because it's effectively, it's like a class, right? I mean, it's not. It's a structure, but it's like we're using it for that kind of same idea. Speed values and player variables, you can see it like a config. Yeah. Oh, I see what you're saying. Yeah, I think so. I mean, we'll see. We may end up reorganizing things later, but we'll see. Right now, the goal is to kind of break things up a little bit and see how much easier or more complex that makes the code. Didn't use zero page addressing for game state. Okay, why? What is this? Oh, and load new game state. Right, so this is segment code 0. And then this is a subroutine, right? Yeah. So we're going to do the same thing as before. We're going to say proc load new game state. And proc. All right, so that puts it into its own scope now, like we would want. Cool, so that zero page is also persistent when changing banks. Well, yeah, the zero page, I mean, all the RAM is persistent in the base 2K of memory. That never changes. The RAM that would change is if you had like bankable work RAM. This is garbage. These are all the variables. We could potentially even extract those out if we wanted to. That was something that he had done with his code. I'm not sure I'm going to do that personally. I don't think we need these bytes. I feel like this was something we had done a long time ago just to see that you could do that. Oops. No, I don't think this is even, yeah. Just call that macros as kind of like a general. So that cut down that code quite a bit. So then this, get rid of that. And move this into its own file. And then similarly, this is going to be then I don't need that, and I don't need that. I just need end proc. Okay. We may end up needing to create folders to organize these separate files differently, but well, so this was already a subroutine. So no, not for that in particular, but as I was kind of getting at earlier, anything that is a subroutine that you're calling does have some additional cost in terms of cycles, which is why initially I wasn't using any, and then I started using some a little bit, but we're gonna use them a little bit more just because think we probably should, in order to keep the code a little bit more organized, I'm also going to switch this to camel case. These can all go into here. And want to, for any of the subroutines we have here, change these to use this proc and proc. There's going to be some stuff that's broken. Let's see. 581 in load level. 581. Okay, get rid of that. No open proc 609. Oh, is this because there's another function that I did? Okay. So that's nproc there. That should be okay now. All right. So now let's go fix where we're referencing the old names. Load level. So this is an example of, is that cycle, hold on a second, is that cycle penalty in pushing and pulling values to and from the stack? It does push some stuff into the stack automatically. I believe it's just the CPU flags and the return address. Let's see. Let's take a look and confirm that. I'm pretty sure that's correct. JSR pushes the address -1 to the next operation on the stack before transfer. Subroutines are normally termed RTS. So it's just the address. Thought it was the CPU flags also. But I could be wrong. I mean, at the very least, it's pushing onto the stack, which, you know, adds cost. And then returning pops off the stack. Program counter address, which points to the last byte of the jump, blah, 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 blah. Stack container. The stack byte contains the program. Just sort of transfer address following the jump program, thereby directing. Okay, it doesn't transfer the affects no flags, causes stack pointer to be decremented by 2. So it's just the address. It jumps, it pushes the address -1 to the stack, and then it goes to the actual code, executes the code until RTS is called, and then RTS pops the address off the stack to go back to where it needs to go. So that's the expense of it. One other thing he showed me that I definitely need to stop looking at my phone. One other thing I definitely want to show is if you switch to using these procedures, there's an added benefit, but I'll get to that in a second. Address size specifier expected. Load title screen. What did I do? 1. That's why we got to do that code. Oh. We definitely want to have that code 0 there, but okay. No reference to unnamed label. Low level, that's in load new game state.asm 37. Load level. Okay, and then we got to fix the audio stuff here in a moment. That audio file that I have, I don't even remember what it does, but that is okay. Is this a subroutine? It is a subroutine. So you are now proc add to score and scope and segment code 0. Is there two? Are there two things? Proc add to score and score. No open. Oh, not scope. Sorry, and proc. Was on like autopilot there. Okay, so audio.asm. This is a return. So proc initialize audio and proc and segment code 0. And then load level.asm. And that is line 540. Next adder. Where is that? That's interesting. Where is that jumping to? It's jumping to that. I wonder why. Wonder why that's not happy with that anymore. Huh. Okay. So we'll do the skipping jump trick where if it's equal, it skips over and then it just does an absolute jump instead of that. But that's weird. Okay. I just wanted to make sure there wasn't another label called next adder that it was trying to get to that was causing this problem. All right, so we built it. Let's reload the ROM. Will this work? Probably. We'll see if this broke anything. I don't know why it would have broken much of anything, but you never know sometimes. Let me connect my controller here. Remap the input now. Possibly. Let's restart mess in here. Oh, good. Okay, so that worked. Yeah, so we're basically in the same state that we were in last time. There's definitely some sort of bug with the first projectile. If it kills an enemy, it will... Seems like it's hanging around after the enemy is dead. But we should see that the palette will transition when we hit the end of the scrolling section, and then we'll get the actual map popping in here. Last week, somebody had asked about POW and the scrolling, and I still don't have an answer. I will get back to on that. That was I think it was you, Drozerex, but I will get back to you on that. I don't know the answer. All right, cool. So we are still working, so that's good. Now, one of the things he showed me that I wasn't aware of when you do... Oh no, why... Well, so that's because I guess that's all we've got right now. So these are the only functions we have. We break things out into more functions, like we've got vblank here, then we will be able to see like what calls are going on here and how long they are taking. As you know, part of our code. So it's going to help us do performance profiling as well, which is important. And having everything all in one function and or all in one big long thing of code and not broken out into procedures or subroutines means that it's a lot harder to see that performance in the profiler. Access to a debug log, like from the NES game itself. Let's go. Keep going through this code. We're actually making pretty good progress, just kind of plowing through this. So like even this, game running output to console. No, there is no way that I'm aware of that you can log like real console log content. I mean, I know this sounds ridiculous, but the size of the text that you would be including would be pretty large compared to the game binary. So if you wanted to do something like that, you'd probably have to, you know, have it be like something you could, excuse me, turn on and off, rather than making it something you would have for everything. Like in modern code, right, you log a ton of stuff, errors, successes, you have different log levels, all that kind of stuff. It's not realistic for what we're doing here. I don't think we need any of that stuff. So this is our code that is initializing our memory, right? So do we really need this to be like this thing that's just in the middle of our code? Right, yeah, I get what you're saying, but like think about how many bytes that text is for all the things that are happening, and think about how small NES games are, and you'll start to realize, I think, that logging text would be a pretty large percentage of the overall code size if you had actual complete logging like that. I don't know that there's ever been anything done where you could like inject, like I could see something where you could inject. That might be kind of cool. So like maybe you have some way of injecting log messages externally to the ROM where it could get triggered by the emulator. That would be neat. That would work, because then it's not actually embedded in the code, or it's not affecting the code size. You'd put like directives in your code that then get dumped out to an external file that could then be looked at the emulator level. So like when you hit an instruction, like you hit the address for the instruction here, it would see that there's, you know, maybe you have something like this where you say, you know, whatever. Right? and then it would say, okay, at this address where we're doing this bit 2002 hex, we need to log. And then the emulator is responsible for kind of matching those things up. That would work, but having it in the code itself would probably not do it. I mean, that's the thing. It's not really a compiler, right? Like the assembler is just taking my instructions and turning them into bytes for the most part. Like there's some more that's happening with some of the things like we were looking at with the procedures and whatnot, but it's not like in C where you write a, you know, where you're like, okay, so I'm writing, you know, a simple loop where I've got some array and I'm initializing the values 0 to 100, 0 to 99 for whatever reason, right? And then the compiler has to look at this and determine like what's the best way to do this. Should it be using an actual location in RAM for the index, or could it use a register to speed this up or whatever? And then in debug, it'll use RAM so that it's consistent with it's easier to debug, so you can actually look at the value instead of having to know what register it was put into. And then for the array, it'll, in the memory, you know, before the array, if you were looking at it, you'd have some sort of, you know, sentinel values before the array, and then you actually have your array values, right, of whatever it is, and then you have your tail sentinel values, and then every time you return from a function, it looks to see if those were ever modified, and if they were modified, it tells you that, you know, you tells you that you had a buffer overflow, and then in the production, in the release mode, it, you know, doesn't do that. Like that's what a compiler would do, because the compiler is taking this code and it's turning it into basically this code, right? For assemblers, there really isn't any such thing. Like the only thing we're doing with the assembler that has to do with debug is we're telling it to produce just show me. Oh, that's not what I wanted. Where is it? Yeah. The only thing that we're doing as far as debug goes is it is putting together, like, here are all the variables, here's where the address is, and like putting this together so that the assembler the emulator has hints as to where the thing lives and what the symbols are, so that it can display that when we go into when we go into the debugger here, and we, you know, something I don't talk about is I just automatically go into, I use the shortcut to, where is it? I don't even know where it is. Control Q, switch to source view. Switching to source view is using this file to pull in the fact that there are all these different files. Like, it doesn't do this automatically, and you obviously can't do this on a commercially released ROM because you don't have the information. But like the fact that I can do this and I can highlight over button flag and it can tell me where it is in CPU memory, and then pull the value for me to look at, it's all happening because of that file. So yeah, so there is no really like debug assembler, production assembler. It's not rewriting my instructions to optimize it for me, or anything like that. Let's see. So I think these are all, I want to say these are all kind of garbage things that we had previously that I don't need anymore. I don't remember. Let's just comment this out. We don't want to comment. Come on. We don't want to comment out this. We do want to do, I think we probably want to make these methods There was audio that was implemented just like as a test to prove that we could make it work, but none of it is used right now. All right, so let's... Let's see. So we're basically just going to offload these into subroutines. Right? I just wanted to make sure we had the RTS there. We do. Okay. So now this all becomes just, you know, clear that and clear this, right? And then we're going to say include clear object and use asm include. And good old segment code 0. Okay, and that didn't break anything. So if we reload, let's make sure that, yep, see, all that stuff is still working the same way that we expected it to. And if we go to performance profiler, you can see we're starting to see more functions here that are getting called, right? So even like clear object entities, right? We see it was just called once, and it might have been, we might go, oh man, that was 1,300 cycles, but like we only did it once, so who cares? We can sort by call count, and we can see check player collision is being called all the time. The amount of time percentage-wise that that's taking is not that much. Waiting for the vblank is taking 2.3% of our code time. So this is the kind of breakdown that that, you know, we get by being able to put the labels in. So let's keep going. Making good progress here. And now the code is becoming a little bit more clean, right? Like we could do this too. Do this here. So like, okay, here's a good example of why you might argue against doing something like this. So you can see right here, I'm doing transfer X to A, and then I'm doing my clear mem, and X, I don't do anything to initialize X or whatever. And you could say, well, now in order to make this safe for use in a function, I've got to explicitly load X with a 0. What you doing? Why did it do that? That was weird. What's going on? It's like shift is stuck or something. That was weird. You could say, okay, well, it's a waste to have to do that. But again, it's like we're only doing this once in a while. It's one instruction. If we decide that we need to do this more often, we can optimize that and, you know, have this be something that we can have a little more control over. But honestly, it's probably just nicer to have it be a subroutine, right? And it's just not polluting up our code anymore. I'll just say we waited for v-blank and we cleared the memory. And then what is going on here? And then we cleared the projectiles, we cleared the objects, right? That's like super straightforward. For the debug logging, by writing to RAM, this reminds me of writing print statements, albeit more low-level and high-level languages. You would need something that would compile these logs when needed, debug, and ignore. Yeah, so you're Drozerex, you're right about what you're saying. Like, in Windows, for example, there's the what is it? I forget what it looks like. The debug string, output debug string, right? So output debug string you can use to output debug messages to the output when compiled in debug mode, and then in release it essentially does nothing. Like the code is just essentially, I think it probably, if I had to guess, it probably compiles. It doesn't even define a function. It probably is just like some sort of weird substitute where it just kind of gets rid of it completely so that you don't have to worry about the debug string. I'm pretty sure that that's right. And you could, and then, you know, depending on if you're running in debug mode or compiled for release, then it would have no, it would not impact performance by having. Oh, so this is different. This is, so this is with event tracing. It's a little bit different than what I was thinking of. There's something in my memory that I'm thinking of where it would essentially actually eliminate the calls, but I guess it's not that. Well, it would be a combination of two things. CA65 would have to know how to generate the right information for the emulator, and then the emulator would have to be able to use that just like what we're doing right now with the debugging information about like where the variables are in RAM and whatnot. Like both sides have to understand how that works, or how that work. Excuse me. They both have to understand how that works, or you're not going to get the full picture of what's going on. I mean, that said, hey, how's it going, Mauser? $12.99. That said, I think it's a cool idea that you could do that, where the emulator is responsible for understanding what the logging looks like and the syntax of the logging, but then it doesn't affect the ROM at all. Like it's outside of the scope of the ROM, and it's tied to when certain addresses are executed. So that it wouldn't affect the actual, you know, speed of the ROM in any way. But anyway, very cool idea. I that's all that said, I think that's a neat idea. Wait for v-blank. I'm going to change the way this works because it's this. I mean, this is a subroutine, but we're going to make this conform to what we're changing everything to. Right. everybody's going to complain about not knowing. Okay. Good. So that's now been renamed. I don't know. Oh, so this is loading. So this is loading the game, some of the base characters to the character RAM. I don't know that I want to necessarily change that right now. Still JSR when it's proc. Yes, yeah. So bear in mind, this is just syntactical. What this does is CA65 treats this as wait for v blank colon scope wait for v blank. Oops. Then you get your code, right? Then it ends the scope. So it's just like a shortcut way of writing this, and it encloses everything in scopes. So it saves lines, and then you don't have to remember to put things into scopes yourself, so you don't have to worry about the reason you use the scope is so that you don't have to worry about things like labels conflicting where you have multiple labels with the same name. So that gives us that gives us that automatically. It just kind of saves us having to write that for now. So okay, so like this code too, reading the controller stuff. Let's make that. So I don't know why it's loading that with 2 and then then loading it with 0 afterwards. It must have been just old code. All right, so same thing. Let's say update controllers or update controller. Just gotta remember to put the RTS or things will be unhappy. Oh, and of course, segment code 0. Okay, and then now that we have that, this is going to do our read of the controller like it does today. Okay, so and if we go check, everything should be happy like it is before. Oh, I broke something. Okay, let's see what we broke. Reset B? Why? That's interesting. Why is it calling reset B? Huh, what happened here? Oh, it's calling this. Okay. Oh. Interesting. So... this the problem? I would love to know why my keyboard is doing this all of a sudden. Actually, we don't even have to do that. We can just do this. Okay, so that's the first issue we ran into. So the problem was, I guess, the label. You can't use this label jump back for some reason, which is fine. So now what's the problem with clear mem? Clear mem. Load X0. Store A. Okay, that looks fine. Is that just a naming thing that was causing a problem again, too? Let's see. Unofficial opcode. Right, let's do segment code 0. Actually don't need that. That jump is pointless. Why are we storing that in 5000? I don't know. What is that even? Is this junk that I'm doing? Or is this related to the mapper? It's possible it's related to the mapper. NROM. That's what we're using. Header. ERC6. What mapper am I using? You? That can't be right. Yeah, it should probably be a constant. Program data, character ROM data, blah, blah, blah. Mapper. So the lower nibble of the mapper number, which is 2, and then, oh, so it's 22 hex. Plus 2. Is that 34? 34, so mapper 34. Oh yeah, BNROM. Okay, I just want to make sure that I had that right. So Address 5000. Is that anything specific to this? It doesn't look like it. It looks like this is just some junk code that I don't need anymore. All right, so clear mem. What is the problem with clear mem? Let's take a look and see what the assembly code looks like and what's going on that's causing this. Because it's saying there's an illegal instruction, but we're not doing anything sort of out of the ordinary here. My keyboard is doing something out of the ordinary. I wonder if it's because of the USB thing I just plugged in. All right. So here's clear mem. We're going to load X with 0 and store it into all these things, including controller. And then we're going to increment it, and if it's not equal, we're going to loop back, right? And if we look at our stack, we've got 2 values on the stack. The question is, did we... So this was something I was thinking about before. Okay, so there is a problem with what we're doing potentially. X store X. No, we're transferring X to S. Okay, so what I was going to say is one thing that we got to make sure we're doing is we got to transfer X to S, and we got to do that. That's saying we're setting the stack value. Right? If we don't set that, then calling a function will work, but in a weird way, because the stack hasn't been set up properly. So that's all good. Why are there 2 things on the stack? There should just be 1. Because we called one... Oh, there's 2 bytes. There's 2 bytes on the stack. Okay. Yeah, that's fine. So if we loop until... Oh, because we're clearing all the memory, including the stack. Okay. Okay. So that's pretty funny. That's a side effect I did not expect to see, but makes total sense. So let's explain that real quick here. So the way that the stack works is it is always in a specific range of memory. I believe it's at the end of the 0200 memory range, but let's double check. It could be different. Oh, it's at the end of the 0100 memory range. Sorry, I couldn't remember. What we'll do is let's restart the ROM. Before the clear, we'll look at that memory range. Okay, so we push these 2 values on the stack, and what you'll notice is if we go to the memory at 01FF, we have 97, 87, and 98. Those are the 2 values we pushed onto the stack. They're here in memory. And there's no explicitly different stack memory. And so what ends up happening is that when we clear the memory, we're clearing out the stack, and that is then clearing out our return address, which means it doesn't know how to return properly. So it's returning to address 0, which, I mean, technically you can do, and then that's going to run the data that's at address 0 as your code. This is something that you can't do, as I understand it, you can't do it in modern architectures, like modern CPUs, because this is how different types of memory buffer exploits work, where you write outside the bounds of a buffer, and then you would jump to execute the code that overran the bounds and updated the memory with instructions, essentially, you know, because instructions are just data. And so you'd return back from your function call by popping the address off the stack, and then you'd start executing the data that was written into RAM by the buffer overflow, causing problems. And so now there's data execution prevention on at least, I don't know how long that's been around, but I know it's been around for a while, to prevent you from being able to do something like that. Can a proc run out of scope? I think there's a limit to how many scopes deep you can nest scopes for the assembler, but I don't think there's any other limitation. So how do we want to do this? I definitely want to clear that memory, but if we're gonna do it within a function, that's not gonna work. Okay. We could skip clearing this range of memory, but then it's like, well, we really want to do that. So what we'll do is instead, we'll make this a macro. Make this a macro so we can still use it like we want to. But it's not a function, so we don't have to worry about the stack being overwritten. Oops. And then should just be able to do this, I think. And let's reload this. That was a pretty interesting problem. I hadn't really considered that at all, but yeah, so you can see that we're running this code here as that's the macro, but it's not, it's considered like, I mean, it is, but it isn't, right? It's just this one thing, but it's really all this other code. So now the problem went away, and if we go look at our RAM, we've initialized it so that it is all zeroed out like we want it to be, except for the sprite DMA shadow copy that we have in the 400 hex range that's set to FF. So now the stack is safe. We can clear the projectile entities, clear the object entities, and then continue on. And we're back to things working again, presumably. I guess the keyboard doesn't really like stuff plugged into the USB. Let me plug this into my monitor. Oh, what am I doing here? Sorry for camera shift, but move the monitor a little bit to get this into the USB port. Okay. I'm gonna have to restart this. We're gonna go for about 5 more minutes, and then we're gonna wrap up here for tonight. Yeah, cool. Very good. Okay. So if code needs to affect everything, it should be in the main assembly file or not done as explain your question a little bit more, because I'm not sure I understand what you're getting at. All right, so we have that, and loading tiles. Oh, actually, what's kind of cool is, yeah, we can go back and look at the bugger and look at the performance profiler again. You can see update controller now is being called. We have all these other subroutines we're calling too, right? All right, so what else do we need to do? So we have these checks for game state. Procs are scoped. They can't affect all the code. I mean, yes, they can. So they can. They can by like modifying variables and stuff like that, right? Like there's still all these variables are essentially globals, right? Um, what the scope does is prevents things like header collisions. So not header collisions, sorry, label collisions. And if you define things like structs, I think also they're contained to a scope. So you don't have to worry. Like if you wanted to have a struct that's specific to something where you don't need it anywhere else, you could define it in just that scope. Um, so well, to be clear, scoping is just a trick like that CA65 is doing. It doesn't have any effect on the code itself. It's just a way of keeping the code a little bit more organized to ensure that you don't accidentally reuse a label or something like that that causes a problem. Um, so saying non-scoped hardware animize doesn't really mean anything. Like the scope doesn't impact them at all. All right, so one thing that Felipe showed, which is kind of an interesting idea of how he did some things, was he had this. So like normally in an object-oriented game, right? You'd have an array of your entities, and at least one way you could do it. You have an array of all the entities that are live in the system, and you loop through them, and it only contains a list of things that are live, right? So it would be depending on how you implemented it. If you implemented using sort of like a dynamically sized structure, like a vector or something like that, which most I think probably most game developers on higher end games wouldn't, because of the expensive potentially having to resize and the cost of resizing the array. But let's just say you have some sort of set of objects that you're processing, and you know that they're valid, and what you would do is you for each of them you'd call an update function, right? Like to process their, if they have to handle the input, they process the input. If they have AI, they process their AI, stuff like that. um it's harder to do that in assembly here because like you don't have that sort of capability. You're doing things like check this, and then and then call, go into that label to do whatever needs to be done. And he was looking at this and came up with a neat trick for there's a way to use the fact that RTS pops things off the stack to return to the code that you were at before when you call a subroutine. He used that RTS trick, which is used for, I think, a lot of games have tables of addresses that you can use that trick on for certain key functions. I'm not honestly, and I'm sure it probably sounds this way too, I'm not 100% sure of scenarios and how it's used normally, but in this scenario what he does is for everything, like every entity that's live in his code, what he does is he stores the address of the subroutine that that is that needs to be called to process it. Like I've got, for example, I've got this here, right, which processes the little bit enemies. He stores that address and then later uses it so that he can dynamically just call this without even having to know what entity type it is. He just basically is like, okay, is it valid or not? And if it is, then call whatever address it's given me in this array to process the game logic on the entity, which is really cool. Like, that's a really smart idea, how to do that, because otherwise you end up with what I have here. So like there's all this other code we're gonna have to go through next time for the refactoring. If we continue that, maybe we'll kind of, we'll see. I don't know if we're gonna continue this. We'll see what people think. If people like this and they like what they're seeing, obviously comment here now, but also in the video below on YouTube, or just reach out to me and let me know, because I'm finding this actually really useful, and it's like making me think about my code a little bit more, and I think it's going to help once we get back to actually working on the level. But at the same time, I don't want this to be boring. I'll just do it off stream, just so it's simpler to get done. Would it make sense as a 0-page episode? Yes and no. Yes, it would make sense in terms of like a supplemental episode. No, not in terms of the sequence of the episodes that I have kind of planned. And I know that doesn't mean anything since I haven't released a 0-page episode since let's see, I'm gonna out myself here on stream. I believe it was earlier this year, but it could have been last year too. So let's see. There was this one. No, that was last year. And then, yeah. So it's been a while. So I didn't realize that it was that long ago. But yeah, it doesn't, in the sequence of things I have planned out, for whatever that's worth, it's not, it wouldn't, I think it would be a later episode once we're kind of past things. Yeah, I think it's worth doing. Like, but I'm still too early on in this refactor to feel confident that I can put together an episode that is clear and actually makes sense, if you understand what I mean. Like, the other stuff I put videos together on, I felt a certain level of comfort with the material. So putting together a short video of what that actually is supposed to do was possible. For this, I'm still exploring this, so I don't think that I'd be able to do this as a video for the 0 pages for at least a few, for a few more weeks anyway. If not, maybe like when the game and the project are done. Like, I think that's more of a post-mortem kind of thing for me. To look back. Yeah, exactly. Look back on it. So, yeah. So, like, the other thing you see here is, like, we have these things are all here, like this. And they're like this because I'm calling them as labels that are being jumped to, and then they're processed. But let's say that we have an enemy type that I implemented really poorly. Let's say for some weird reason, the explode processing is really inefficient. Doing it this way, I wouldn't know, because it's not a subroutine that's being called. And so the fact that it's not being called as a subroutine means that I'll just know, okay, the game isn't running well, but like, why? And I'll have to narrow it down, versus putting it in a subroutine. That profiler will help me, But then again, we could try Felipe's trick with the return and do that so that we don't have this. This is what I was getting at before we went on that tangent a moment ago. But like, so we have this loop here where we're just doing load the type, compare branch, compare branch, compare branch, compare branch, compare, right? Like we're doing all of this stuff. And this is because we have to look at the type value to determine what code we want to execute, versus saying, okay, at the time we make the thing, we know what code needs to be executed, so get the address of that and store it into the thing. And yeah, that takes up 2 more bytes, but then on the flip side, we don't have to have all of this code. We just have a loop that loops through all the entities and says, okay, are you a valid thing? So, you know, branch if equal to skip entity, right? Which is, or not even, like done with entities, because I don't think we allow for gaps in the entity list. Oh, but you might get them if an entity expires earlier than a subsequent entity. So you gotta loop through the whole entity list. You gotta loop through the whole entity list, and you have to say, okay, are you a real thing? And if you are, then use the address and just call the code, whatever it is, and you call it. Presumably, you'd call it with something like JSR, so that it pushes your address into the stack, so that the return then comes right back to that loop, and you just keep doing that until you're done. And it's a much more compact loop. You don't have all this nonsense here. Clearing the object entity could be probably a subroutine too that gets called within it, but that's a whole other thing. Here's an example of something that we probably... Let's see, what is this doing? This is just literally setting an address, so that doesn't really... Oh, okay, but draw sprites is actually drawing the sprites. That's not... I don't want to mess with that right now. Wait for draw to complete is what it says it is. Check bullet collision. So that's a subroutine, so let's fix that so that it actually looks like the rest of them now. And then we can move this to the rest of the includes up top. That just goes back to the game loop. Here's a for no reason at all, we just have this just dumped in the main file. So let's move this out of here. I mean, I know why it's here, right? Like it's purely just it was convenient to put it there, so let's just do it, because I'm, you know, fighting to make the code work in the first place. But now that we're taking a look at this, it's like that's kind of a garbage way to handle it. So what did I search for before draw sprites? So check screen mem. This is also a subroutine that doesn't need to be in our main, defined in our main file here. That's 1124. What was the thing we just did? Add map object. Just occurred to me. I didn't. Did I get rid of that? I did. Okay. Thought I left the scope in there, which we don't need because we're using proc. so that's good. And then we were at 1124. So add projectile. This is another thing that we just, dumped in here. Segment code 0, add project, oh. Keep forgetting to remove the colons after the names. Okay, so that cleared up that. No, my keyboard is just being junky today for some reason. Okay. And then we're in our VBlank, which I should really just rename NMI because that's what it actually is. I don't think we're using that anywhere that isn't just wait for VBlank. Wait for VBlank. Yeah, okay. So we've renamed that to NMI. Bedtime for me. You're welcome. No problem. It's getting late here too. I'm over my own imposed time limit, but I was actually having fun kind of getting this stuff shifted around. So thanks for joining. Good night. Let's see. Do we have any other RTSs? We have RTI. No. Okay, so we've removed all the methods from here. The code still has a lot in it. But like when we look at the beginning of it, I mean, we could even do macros for like this part too, right? Like the base initialization, but it's like, okay, we wait for VBlank, clear the memory, clear the projectile entities, clear the object entities. And of course, what we're doing here is we're setting, certain values for this here that are different than just 0. The idea being that we could potentially reuse this now later on, where I think we are doing a similar type of thing. And then we go here and we are, what are we doing? We're setting up scroll Y. They have the entity counter. We're waiting for VBlank. We're storing that into 2006. Then this is where we're doing our setup for the memory, the RAM load. We could probably put this into a method, like some sort of procedure where we could tell it what we actually want it to copy. So like right now, it's kind of fixed, but we could potentially turn that into its own subroutine. So then we initialize our audio. Set the game state, we set the sprite mem addresses, we store our swap value, we set up our DMA, copy to clean up everything. We set the camera counter speed. We allow for the interrupts, and then we have our game loop. We get our controller read. This stuff could probably be cleaned up here. We've got a ton of stuff after this that definitely needs to be cleaned up, like for the logic around the map updates and stuff like that. So, but there's a lot of other stuff that we did that got code out of here. We need to, yeah, there's a lot in here that we need to kind of take a long, hard look at and, you know, understand. Like, so this code is specific to the player, right? So, like, we could just do something like just process player input instead of all this stuff. So all that stuff can go. Put this into here. That's our label that we're finished. Oops, and then don't want to forget that. Oh, and then of course, I still always forget this. All right, so now, again, it's like, well, what did we accomplish? Well, what we accomplished was now all of that code is not here anymore. So that's like, we know what we're doing. And one thing that Felipe pointed out that was useful for him, which could potentially be useful for us, is, you know, like, if something is not working, it's much easier to just do that to remove a subsystem of your game than it is to have to comment out a bunch of code where there are like intermesh dependencies, and then it's like, oh man, you know, did I even comment out the right stuff? Right, yeah, that too. So now it's all in a very clear location. Like, I don't have to go searching for where we're processing the controller variable. I just know it's here. So make sure it's not broken again. Yep, so my player input still works. No problem. The projectiles are being added. The enemy ships are still spawning. All that's good. And it's just in here. And then I know I keep harping on this, but like, I really think that this is a critical thing. I can look at, okay, processing the player input. It's happening so many times per game, and this is how much of the CPU cycles it's taking up. So if I want to look at like what on average is taking the most cycles, so load new game state was the main thing. Wait for vblank taking a pretty long time, and that makes sense because, like, if you think about it, it's just kind of wasting cycles, you know, waiting for the vblank to occur. But then the next one here is load level. And again, that also makes sense, right? Like, because we're doing a lot of work to get the level loaded and decoded and all that other stuff. But if we were wondering, like, why does it take so long for it to load the level in or the background in or whatever, well, we can look at the cycles and we can very clearly see what's going on. This now actually says NMI instead of VBlank. We can see that, like checking screen mem is not doing much, low level objects not much, object check, player input check. Like these are all kind of doing the least amount of work, around 90 cycles for that, right? So that's really, really handy that we have that, and that'll be even more handy as we have more stuff happening in the game. So yeah, so let's end it here because, like I said, it's later than I wanted it to be. I've got some stuff I got to do tonight beyond this, so let's wrap this. But that was really good. I think that we accomplished a lot here, and I'll look more into the thing that I was talking about with the memory and see if I want to do that or not. I think I'm probably going to want to because I really like the idea of that and it reducing the code here. But yeah, so we have a bunch of includes now, but it's a lot cleaner. Like we really know what's going on. I mean, we could probably end up with the same thing that we're going to check, or that we're going to do with maybe like our variables potentially. I don't know, like the 0 page. But I don't know. Oh, these are constants. And guess where they belong? They can just go in our constants file. Oh, except it is, let's see. Why do those? Oh, because so this is a case of chicken and the egg. Let's move the constants after the definition of the type there. Let's see if that fixes it. Needs to know what the struct is to be able to determine the size, obviously. So that's why that was complaining. Anyway. All right. So as always, thank you for watching. If you want to reach me, I'm on Twitter at Clairvis. I am on Video Game Sage as Zelius. I am on Discord as Clairvis. You can email me at zelius@gmail.com. Feel free to comment in the recording below on YouTube. Don't hesitate to ask questions. And thanks for watching tonight, for those of you who are here live, and I will see you on Thursday. Have a good night, everybody. Take care.